Okay, so here we're dealing with a standard mole conversion problem. And so we are working with oxygen gas. Okay, so O2. Because we've got that, it's O2 because it's diatomic. We are told that we've got molecules and we are asked for mass. Anytime we see the word mass, we know we're going to need a molar mass most likely in that question. So it's never a bad idea just to, as soon as you see the word mass, go ahead and calculate that. Then, just like every other problem for this course, we're going to go ahead and begin with what we are given in the class, in the question. Okay, molecules on top, I need to have molecules diagonally. We know that 1 mole of any compound is going to contain that 6.02 times 10 to the 23rd molecules. And if the question had asked for moles, we would be done here, but it doesn't. It asks for mass. And so we need to keep going. And to go between moles and mass, we use molar mass. So we go diagonally with 1 mole and go ahead and stick that 32.00 grams on top. Remember, molar mass is always some number of grams per 1 mole. So we go ahead and plug that into our calculator. Remember to be using the E button as you do these calculations to help keep straight your order of operations. And we end up with 6.49 grams. Okay, then down here for number 84, it says how many atoms of oxygen are in a 93 gram sample of perchloric acid. So we're going between grams and atoms, which is, actually a pretty long train track to be dealing with, but that's fine. Okay, that's about as long as it gets. And so the first things first, again, we see that word gram, and so we know we're dealing with a mass, and so it's not a bad idea just to go ahead and right off the bat calculate that molar mass. Okay, and so perchloric acid, we've got HClO4. And that's going to have a molar mass of 100.46 grams per mole. And then we start with what we are given in the question. Okay, so we've got the 93 grams of our perchloric acid. So diagonally, I'm going to have grams. We just calculated that molar mass, which told us that we had 100.46 grams in 1 mole. Again, molar mass is always some number of grams in 1 mole. All right, if the question asked for moles, we'd be done, but it didn't, so I know I have to keep going. And so I stick a mole on the bottom here. Because we are talking about a compound, the representative particle for a compound is a molecule. So I'm going between molecules and moles. And we know that 1 mole is going to contain 6.02 times 10 to the 23rd molecules. We do need to keep going because we don't want molecules. We want atoms. Molecules are made up of atoms. If the question had asked something like how many atoms total are in the molecule, we would be counting all of these, but because the question specifies that it really wants the atoms of oxygen, not just atoms in general, we're going to say, we look back to that formula and we see that there were 4 oxygen atoms. And so in 1 molecule of perchloric acid, we have 4 atoms of oxygen. Okay, so the last thing we need to do here is go ahead and plug that into our calculator. Again, be careful with your sig figs. Remember to use the E button for Avogadro's number. So we've got 2 sig figs in that given, so our final answer can only have 2. We plug that in and we're going to get 2.2 times 10 to the 24th oxygen atoms. Okay, number 85 here is also dealing with a mole conversion problem. I apologize, there's definitely a typo here, okay? Lithium atoms and cesium hydroxide, that's not a thing. I'm going to go ahead and just pretend that the question said cesium. because cesium is part of that actual compound. Again, my apologies there. Okay, so seeing that word grams, again, gives us that clue that we are going to need a molar mass of this compound to do the problem. And so our formula for cesium hydroxide is CSOH. And so when we plug that into our calculator, we're going to get 149.9 for the molar mass. Because cesium only had 1 decimal place in its atomic mass, when we take that to plug it into our molar mass, we're going to carry off that 1 decimal place for that molar mass. Again, we're going to start with what we know about from the question, which was our 12.25 grams of cesium hydroxide. So this question is very similar to number 84. We're just going to run through these train tracks. There's 149 grams of cesium hydroxide in 1 mole. In 1 mole of cesium hydroxide, we have 6.02 times 10 to the 23rd molecules. Okay, and then in 1 molecule of cesium hydroxide, we're going to pay attention to the question. Again, I changed it to cesium atoms. So in this molecule, there was only 1 atom of cesium. Okay, again, reading carefully what that question is actually asking for in that final step. Again, it wasn't asking for how many atoms total there were. It was asking for a specific element in that compound. So we go ahead and we plug that in and we're going to get we check our sig figs, 344, 4.9196, okay? And so this is a great example of significant digits. We only want 4, and so we cannot use that 9 anymore. That 6 makes the 9 round up. And so our actual answer is going to become 4.90 times 10 to the 22nd atoms. Okay, and that ends the mole conversions.